Hi class. So we're going to be looking at this simulation together. So we're just looking at a few factors and how they impact the population growth of a species in an area. So here we're looking at these Averil tuna in the Averil Gulf. And first thing I want to do is when we go to the simulation is kind of play with it and figure out how different factors are influencing the population. So for this, we're only given a couple factors. So we're given reproduction, migration, and death. So if we go through and kind of change them one at a time, well, we should notice the following. Obviously, higher reproduction, so we'll add a little arrow here, but if the reproduction is higher, okay, that's increasing the population. If death is high, that's going to decrease the population. And actually, if you just change migration all by itself, you'll notice that if we have high migration, so that means fish are moving into the air, oops, not migrations, just migration. That means fish are moving into the area, so that's increasing our population as well. So this is what we should be looking at. So in stage one, we draw our normal. So this is like our normal here. So normal curve, no changes. So no changes. Sorry, I kind of switch colors as we go, but in this case, normal is green. And then I changed to increase the death rate, and I got my blue there. So I should notice a few things and I should be asking myself some questions. So first, obviously, the blue line where I increased the death is lower than the green and normal line for the first, I don't know, let's say 5-6 years. So that means that it's decreased the population compared to normal, because we're going from here all the way down to here, okay? So it's decreased that population within the first 6 years or so. But then I should be asking myself the question, like, what the heck? Why do we, and I'm going to use max out. So why do we hit this maximum? Why do we hit a maximum at 100,000 fish? Why is that happening? So if we think about just some of the factors that we might consider as limiting to population growth, so why aren't there more of them? Then we should be thinking about the following. So remember, resources are limited. Okay, so we don't have an infinite amount of resources, just similar to the screencast from yesterday. So we don't have an infinite amount of resources. So things have to compete. They've got to compete for food and space, and they have predators, and they have diseases, and they have pollution, and they have to fight for mates. So because of these limited resources, that means that our population cannot continue to grow forever, so it's going to hit a maximum of about 100,000 in this situation. So then we look at our second round. So in our second round, we have some new factors. So this is stage 2, so I'm just going to show this at the bottom, and I didn't fill it in. So in stage 2, let me just flip it over and do a quick check. In stage 2, we're trying to figure out what would increase or decrease the population. So first off, it would increase if we have, I'm going to write abundant food, so that's obviously going to increase the population. I mean, the opposite is true for decreasing the population. Obviously, if there's no food, okay, then the population is going to decrease. The other thing is many predators will decrease our population as well because they're eating our fish. The other thing that we'll see in this is that we could get disease or pollution in the Gulf, and that will decrease our population as well. So remember, the opposites are true. So if many predators decreases the population, then no predators will increase the population, assuming that they were there originally. So if they disappear and they had been there, then our population, we would expect it to increase. So when we flip, we see our normal line. So here, this is normal. And then I changed settings. So I think what I did is I just decreased the amount of food available. You can double check when you get to it, but I decreased the amount of food available. And I saw that in the situation where there was some food available and there were some predators, then our max population would be equal to 60,000 fish. Okay, so this would be this maximum population. This is, as we discussed at the beginning of class, this is the carrying capacity. So it's the amount of fish that can be supported by this ecosystem. So this is our carrying capacity. Okay, under the normal situation, there should be able to be 60,000 fish in the Gulf. However, when I decreased the food, so I took some of the food away, I see that that changed the population. So I see now that it looks like with very limited food, we can support less than 20,000 fish. And I saw a couple events as I was going. So I had the pop-up and it said disease and then it said pollution. So the disease and the pollution obviously decreased the population. So that's to be expected. Okay, so now we're going to look at the third one. So in the third one, we introduce fishing to the picture. So there's fishing now for the tuna in the Gulf. I don't know what I was doing. I got a little distracted. It's just after school, so I'm getting kind of tired. But we see that fishing obviously decreases the population of fish because we take a huge quantity of the fish out to be consumed. So if we look at the bottom, okay, now we're just looking at fishing. And we're taking away many of the other factors that we looked at in round 2. So if we look, we go back to this carrying capacity situation, or the situation where we can hit a maximum, so our max number of fish, or the carrying capacity, capacity without fishing, is 100,000 fish. So 100,000 fish can live in the Gulf. Okay, so whoops, let me move this over. 100,000 fish can live there. And then as you play with the fishing, you'll see that no matter when you're fishing, it's always going to decrease the population. By the way, this is a little bit messed up, so I just labeled on the bottom time, and then I added these seasons. So I put that in there, and I actually only increase fishing in winter. So I said there's a lot of winter fishing. So if you look every winter, we get like a chunk of our population taken out. And it's kind of interesting because you'll see that the population starts to recover. So it starts to recover throughout the rest of the year. So after the winter where all the fishing occurred, the population starts to recover, but then it plummets again every winter, because I put that there's a lot of fishing in the area. So the population can never fully recover. It's actually consistently slightly decreasing throughout the years. So I want to label this again. This is normal, and this is my line that I made with fishing. So this is what we're noticing. Okay, it's a huge decrease in population from fishing in just one season alone. So next flip. Now I've got like all sorts of crazy factors that can influence my population. So now I can have, I can change the reproduction, the migration, the death, the predators, the food, and the fishing. So what I chose to do is I chose to alter the reproduction. I chose to alter the food, I think. So I made it so there's a lot more food. And then I made just a little bit of spring fishing. So going through the same process again, I relabeled, so these are my seasons. So SP is spring, SU is summer, F is fall, and W is winter. And I drew my normal line, so green this time was normal. So that's without changing any of the factors that are available to change in this simulation. So then I see this. I saw the few events occur within my ecosystem. So there was pollution, there was disease. This disease was persistent for a few seasons. So several months I had some disease issues in my tuna community. And then I had another pollution event. So this is a more realistic idea of what a population would look like over time with all of the potential impacting factors. So if we have so many factors that influence the population, it's probably not going to be this nice, beautiful curve where it maxes out at this ideal situation. Right? So here, again, our potential carrying capacity was, so for a normal, if I'm looking at my normal where it flattens out, was 60,000 fish or tuna. So we could support 60,000 tuna But I just never got there with all the other stuff that was limiting that population. So now it's saying, for analysis questions, we'll identify and explain different limiting factors that impact the tuna. So, geez, there was a heck of a lot of them. So I want to explain them, but I'm thinking about disease, pollution, fishing, food availability, predators, okay? And this is why ecology is so complicated, because there's just so much involved. So I would pick a few and just describe what you think is, how you think they're impacting the tuna population. It says, how did the carrying capacity change during the different stages of this activity? So you'll notice that in a couple of the stages, the carrying capacity was 60,000. So I note here, the carrying capacity was 60,000 in stage 4, and it was, I'm sorry, I wrote on 2 different sheets here. It was 60,000 in stage 2, and then it was 100,000 in stages 3 and stages 4. So I'm trying to figure out, like, what's the difference between those stages? So what do I think is responsible for that change in the carrying capacity? So if I write, like, what's making the difference? Right? What do I think it is? So if we make sure you remind me, we need to talk about this when we get to class. So what's making the difference? All right, so best of luck. If you have any questions, let me know. I hope this is helpful. Please do play with the simulation. So draw your own, play with it, figure out how it works. It's kind of fun. Okay, you can make it look very different from the ones that I've created. All right, have a good break if I don't see you.